Testing 1, 2, 3, 4, 5. Okay, it looks like I have good audio. I get started in just a second here. Okay, so my name is John Stritzinger, and I am here tonight to demonstrate what is possible in Visual Studio if you are trying to deal with essentially a flat file structure, or if not a flat file structure, then a database system that resides inside a single file, essentially. So you may have some other supporting structures, but in Visual Studio, there are a number of different options that are possible. So in this demonstration, I'm going to show you a couple of those. The first is we have the option to support MSAcess databases, which I have highlighted here. And what I've done is I've taken the student database from MSAcess, which comes as its basic starter database. And I sort of stripped it down to just students. It has some other things in it, like health records and guardians, and there's a number of reports and the like. But I just stripped it down so that it just had the student information that I wanted. In addition to that, I added in a SQLite database, which I created locally. And not only did I create a SQLite database, but I actually put the entire zip architecture for SQLite 3 in my project. And it's so small that it's only 2 or 3 megs that you can actually sync it with GitHub. So if you're working on a team and you have a small data set under 100 megs, or actually under 20 megs for GitHub, you can use this architecture to develop at least some prototypes with a working schema. So this is what I was trying to do. So I am here tonight, and you have seen the files that I've created. And in addition to that, when you build a REST API in Visual Studio, it does create this weather forecast infrastructure. It has a C# file, and it also builds a weather forecast controller. And the controller is what ties into Swagger. So when I run this project, you'll see that it has a weather forecast, it has my student database, and I built a movie database at SQLite. So the 3 different tools are all coming together. Now, the other cool thing with Visual Studio is, although most of the time in life we only have a single database architecture, like we're just talking to Oracle, we're talking to IBM, we're talking to MS SQL. In this example, I'm actually showing that you can have both a codeless API where you're just generating random data, which is useful for diagnostics, actually. So if you write a client and you want to make sure that your REST interface is working, you can just send back random numbers and the like in a formatted JSON structure, and that's very useful just to know that your code is working across network architecture. So that's what I've been doing lately, is I'm leaving the weather forecast in my projects because it's very helpful for me to test client architectures. The other thing that I've done is I built a controller for each type. And when you do that, I have a student here for the MSAcess, and then I have a movie database here. So I have a controller for each one, and inside the controllers is where we're putting the logic, the select statements, the Microsoft Link architecture that allows us to bring all this together. So what you're seeing in the API is all driven from the controllers, and the controllers communicate to models. So the models have the database architecture that you're using, and you can either code first and create the database thereafter, or you can reverse engineer your databases, which is what I have done here. So you'll notice that there are two models and there are two contexts. And sometimes we split the context out. But the context is essentially just a connection string of how you're getting to the database. It has some other items in it, but essentially that's what it does. It also identifies what tables that you want to reference. So essentially the context communicates to the model, and it essentially restricts the data that's coming back into the program. So we have a model, we have a model context. The context is the login, and then we have a controller that is the SQL logic behind it. So there are really three components in this system. Now I put them all together. This is a sort of a summary of a team project that I was working on, and we got some frustrations along the way, but flat file architectures are very useful for things like network configurations, for specifics of the virtual hosting environment that you're working on. And usually they run out of band from your primary activity. So you can keep your configuration data apart from your customer data or your employee data. And that's very helpful as you build larger projects. So this is a very real world type of design. And I just have one table in each one, so it's not very fancy. But I just ran the project, and I'm running on port 8008, which is in the RFC standard for HTTP. And when you do that, you'll see here that I have a working project. I'm using Microsoft's Open API now. They have taken it over, and it returns what they call Swagger. And Swagger allows you to look at all of your APIs and sort of document what they do. And here in this example, I have the weather forecast that I showed in my 3 other videos, and it is working as expected. So you can see that it is returning data. And I've shown you this in Postman and directly through the web interface. So this is nothing new to what I've shown before. So we kept the weather forecast in. Again, I'm using this as a diagnostics tool, and certainly that is good to have. Now, in addition to that, here is the student database. Again, this is communicating to Microsoft Access, and if I try it out and hit execute, it will return, hopefully, all of the soccer players and my kids that I put in there. So I have Lucy and James, I have some friends of mine, and they're all in the database. So this works very well. It's all been tested. And if I insert records into the database, they are going into the Access file that's in the root of the project. So it does get larger over time. In this particular case, in my demonstration tonight, I am here on campus, and they gave me a map drive on a Windows server. So I'm actually have an H drive, which is my home drive, and I'm actually saving my entire project on a network drive that's backed up. So this actually is sufficient if you wanted to run this in an enterprise environment. The ops guys wouldn't hate you terribly if you wanted to do something like this. But it does work for the student database. And if you want to go to movies, this movie environment is tied to my SQLite. So you can see it just has Top Gun, James Bond. These are just the movies that I've loaded in. And you'll notice here that at the bottom, the IDs not in sequence, I inserted my own data, and then I changed it to generate a random number so that the ID is always unique. And I did that because otherwise you have to return the data set, figure out what the last record is, and then reinsert to the right number. So there are different algorithms to do that. Some of the databases do auto numbering, but in this particular case, I just rewrote the code to do a random number generation, and that creates the ID. And the reason I did that is because if you generate a random ID, it doesn't just work with Access, it works with SQLite, it'll work with SQL Server, it'll work with MySQL. So I was focused on building code that could be repeatable, and that's essentially how I did it. And by generating a random number for the ID, it doesn't matter what database architecture you're using, or whether or not you have an auto increment field or not. So as long as the number is unique on a primary key field, it should go into an insert mode. And you can put some error checking in so that if the record already exists, it will error out. So anyway, I've just shown you something very important. You can randomize data, you can run MSAcess and SQLite all in the same table or in the same project at the same time, which is very important. And there is actually a third way to do this with the environment that I'm working here. As in a code first environment, Visualstudio actually comes bundled with SQL Express Lite. And when you do code first, if there's no database that already exists, it will actually create SQL Server Express local files. So not the full database, but a sort of a SQL Express Lite format. They've changed the name of it over the years, so I always get confused. But essentially, it's not Microsoft SQL Server running as a service. It's a Flatfile architecture that uses the same formatting. So it has the same programmatic interface, but it writes to a different file format, if that makes any sense. So these are the three main ways to handle configuration data: SQL Server Express Lite. You've got an MSAcess architecture and SQLite, and all of these should go nicely into your project root. GitHub has a 25 meg maximum limit in an individual file. You can do releases above that. If you change your project setup, you could do like 1 gig files that are downloaded as releases. But you do have to have certain permissions, and they do require some enterprise checking for certain companies. So I don't know that every person has that, but on my projects, if they're in my corporate account, I can create 1 gig releases, but I still have a 25 meg individual file limit. So if you have large data sets, this isn't going to work. You'll need a virtual machine. But if you're just building something in test, it's a very good way to go. Now, using SQL Server Express Lite, you can use the same architecture, write the code, and then when you get larger data sets, you can upgrade. So that's what Microsoft is selling. Microsoft also has an Access upgrade tool to SQL Server that will port all your data. So Access is another way to go, but essentially you still have a 25 meg file limit in GitHub. You can have your own GitHub server on campus. You can install an enterprise version of Git, and if you do that, then it's whatever you set it to be. But as far as the public versions of GitHub, you do have a 25 meg limit. So we have taken you through the important part here. This is a supplement. I guess it's 1A, 2A, B, 3A as part of my project goes. But I want to show one more thing, and that's how I got it to go to that specific port. If you go to the launch settings file and check it out, you'll notice that in the profiles I have specified that port, and you can have Visual Studio serve just HTTP, or you can have it serve a secure server as well. So it will do both. The only issue is that Visual Studio launches its own internal web server called Kestrel, and in the secure server model, it tries to automatically forward from HTTP to HTTPS, and as a result of that, it's pretty hard. It's a much more complicated configuration in Kestrel, so you need a lot more experience. So if you have never done this before, I would recommend sticking with HTTP, and my other videos go into how to build proxies from your core web server into the API. And so if you watch my videos, 1, 2, and 3, they're all about 25 minutes a piece. Then you will have what you need to be successful. So I hope you appreciated this. It took me a little while, and I have put this project up on GitHub. It does have the right architecture to get your CRUD interfaces working properly, and that is very important. So this whole project can be put together in a few hours, and I have been in courses where this whole process has taken months. So I think what I'm giving you here tonight is very valuable advice. Thank you very much. Again, this is John Stritzinger. Please click on the like and subscribe. I am trying to get to 12,000 subscribers on my channel. I'm just starting. When you get to 12,000 on YouTube, you get your own faceplate. So you get like vanity plates. And I have vanity plates on Facebook and Twitter, but not yet on YouTube. So if not that, then I have to get into a better business that people watch. So appreciate your time and have a good evening.